Welcome. Today I will talk about PS and the kill command. PS, it stands for process status. First I will just run the PS command and let's just interpret what is the output. PID, it's the process identifier. This is a unique number that will be given to every process that is spanning or starting up. TTY is what controlling terminal it is. In this case, it's PTS/1. The time will represent how much CPU time accumulatively used this process so far, and the command itself, what is it running. In this instance, the bash command is going to be the terminal that I'm using. If I just type TTY, it will tell me that this is the terminal itself. As you can see, this is the number one controlling terminal. There are other flags we can use with PS. For example, if we have PSE, it will show us every single process that is running on our system. The very first process, the PID, it is systemd, the process that is starting up in the very beginning when we turn on our machine. There is no TTY because this is not running in a terminal. And in the command, there are a lot of different processes that are started up, and we have our own terminal as well here, the 4324, and of course the PS itself, because when I run the PS command, it is a running process and it will show itself as well. With PS we can use other flags as well. The EF, in this case, is going to be a full format listing. This will give us even more information about our processes, and we have an extra column of UID. UID is the user identifier, who is the owner of the process, and the owner of the first process is the root. The PPID is the parent process ID, where this process was spanning from. This way we can actually have a hierarchy of what process forked or spanned from given process we're looking at. The C, this is the CPU usage. At the moment, I can find this one is the only one that's showing up, and this is using 6% of the allocated CPU. The GNOME shell, the graphical interface that we are seeing. The next column is the S time, is when it started the process. The same thing as previously I mentioned, the TTY, the accumulative time the process has used CPU time, and the command is the command that is running. Additionally, we can use other flags that we usually use. It's the AUX, very similar to the EF that I used before. This is the BSD style option, and most likely if you use or Google, or if you've seen the PS command before, you very likely came across the UAX. Let's just break it down. A is list processes for all users. That's the same as the E. The U will display the user or the owner of the process, and the X will include the processes that are not attached to the terminal. So these processes are the ones with the question mark. Let me just run the AUX command, and we see the user, the PID, the percentage CPU usage. We have an extra column for memory, how much memory this process is using. The VSZ is the virtual memory size, how much virtual memory is used by this process, and this is in kilobytes. RSS is the resident set size. This will show the physical memory used by this process, and this is this number is in kilobytes as well. The stat will give us a further insight what is actually happening with the process. S is for sleeping or for running. The I is idle, and the combination of these letters. We can see the R because when I ran the command, I ran as the WGTI user, and it got the process identifier of 21880. At that point it was using 100% of the CPU, 0.1% of the memory. These are the kilobyte values. This is the terminal I was using to run it, and this is the terminal I was using to run this command, and it was running. This is when it started and how much time it spent on CPU time, and the command itself. The information that we're going to use in the following scenario, I have a other terminal open and I have created a script, and this script contains the following. We make the file executable, and now if we check, now this file is executable, so I will be able to execute the following way. After we have an echo, this will tell us what is the process ID that has been given to this script, and the next line is using a while loop, true. This will run forever or until we kill or terminate the process. Sleep is simply just an interrupt. It will be sleeping or idle for 1 second, and after the loop will start again. This process will sleep forever until we either kill or terminate this process. So let me just run the process. As I mentioned before, I can run it this way, and if I press Ctrl and the letter C, it will terminate the process. This is called a keyboard interruption, or I can just do the following. In this case, I put the process in the background, and I can just typing FG, it will bring it to the foreground, but I will just use the / script because now this file is an executable and I can just simply execute it. Now we just take a note of this process ID 23003, and I will go back to the other terminal, and I will just simply run the following command that we ran before. And if we look at this line and this line, so what happens here is we have the script running as I showed previously, that this is the command that's running. Since we used on the first line that hash and exclamation mark, that will tell us that this is how we would like to run our script, and we only had to type this part, and we have the same process ID. But below we have this process, and we know this is the process that was part of the same script because this is sleep 1, and we know, if I just go back, that this is a line in the script. What happens is the script starts, and after it prints the line, and when it gets the while loop and it steps into the while loop the first time, it will start the sleep. And now I just done it one more time, and this ID will be different every single time for every single second, because it will spun up a new process that is the sleep. And every single time when the loop is done, it will stop that process, it will exit, and after start up a new sleep process. And what we can do, if we would like to actually stop the whole script from running, we can use the kill command, and I want to forcefully stop this script. This is not the nicest way of stopping processes, but for this demonstration I'm going to use the tag 9 flag, and I will need to provide the process ID. And when I press return, nothing happens for us, but if I go to the other terminal, it actually tells us that the process was killed. I will start the process one more time. The script, we have the process ID of 23271. And I will use psaux command, and we have the process running here, and this time I will use only the kill command by itself. If I go back to the other terminal, it says terminated. Let me just run it one more time, and I will have it in the same window. And as you can see, when I use only the kill command, in this case it will give us terminated, and when we use the kill-9 command, that's a forcefully killing the process. In that case, it will actually tell us that it was killed. The difference is that the terminated one, it actually, the kill command is asked that please terminate the process, and in that case it will have time to gracefully shut down if we have processes or functions in our script or other applications. If we kill it, that's abruptly terminate the process. There is no time in that case to gracefully shut down. If I start the script again, we can take a note of this process ID. I just copied it out to the clipboard, and as previously I showed in a previous video, we can simply use the grep command to find the process, and we can see that it only lists this only one process. This is really useful if I don't know the process ID. That's usually the case. I don't know the process ID, but I know the command or the script or application that I'm running. In that case, I can use grep, and I'm just providing the name of the script, and it will find exactly the same thing. Again, thank you very much for watching. This is what I planned for this video, and I hope you enjoyed it. And for the rest, we'll get to it.